Hello everyone, Namaskar, welcome to Maths Guidance. This is going to be the last lecture, fourth lecture of this chapter, chapter number 9, that is areas of parallelograms and triangles. And we are going to solve some very good questions. Basically, this is a question and answer session. We are going to solve some very good questions based on all the theorems which we have studied throughout the chapter of parallelograms and of triangles. Alright, so let's start the video and let's finish this chapter. Okay, thank you very much for joining me. So friends, let's start the video, and this is the first question. The question is, in the given figure, ABCDE is a pentagon. ABCDE is a pentagon. A line through B parallel to AC. A line through B parallel to AC means this line BF meets DC produced at F. Meets this produced at F. Okay. We have to prove that area ACB is equal to area ACF. Okay. And then area AEDF is equal to area ABCDE. Okay, so let's solve this problem. Okay, so when you take this as a common base AC, okay, and when you look at this triangle ABC, or here it is written ACB. Okay, so ACB and this one ACF. Basically, these two triangles are on the same base and between the same parallels. Okay, so triangle ACB and triangle ACF are on the same base AC, and between the same parallels. AC and between the same parallels AC and BF, and we have been given that BF is parallel to AC. Okay, a line through B parallel to AC meets DC produced at F. That means BF is parallel to AC. It is given. That means what? That means therefore area ACB is equal to area ACF, because we know the theorem that these two triangles will have equal area, being on the same base and between the same parallels. Okay, so this one is proved. Now let's see the second one. Second one is, we have to prove that area AEDF and area ABCDE. So basically, when you have proved this one, so let us add this area ACDE. Okay, adding area quadrilateral ACDE on both sides. Okay, on both sides we get what we get. That means area ACB plus area ACDE is equal to how much? Is equal to this side area ACF plus area ACD. So in this equation we have just added on both sides this area ACDE. This implies, when you see area ACB plus ACDE, that means what? That means ABCDE. That means area ABCDE is equal to ACF plus this one. So ACF plus this one, that means what? That means A, E, D and F, this one total, that is equal to area A, E, D, F, and this is what we had to prove. So it is proved. So it was a simple question based on this theorem. Triangles on the same base and between the same parallels will have equal area, and then we simply added on both sides this equal area ACDE, and it's proved. Alright, let's move on to second question. Now this is the second question. Let's check it. This side AB of a parallelogram ABCD, this is the side AB of a parallelogram ABCD, is produced to any point P. This side is produced to P. A line through A and parallel to CP, that means this line AQ parallel to CP meets CB produced at Q. Okay, means AQ is parallel to CP given, and then parallelogram PBQR is found. Okay, so we have to prove that area ABCD is equal to area PBQR. Means these two parallelograms will have equal areas. All right, let's solve it. So first of all, we will write that this AQ is parallel to CP. AQ is parallel to CP. It is given. Okay. Now let's do one construction. Let's complete this one. Let's join this AC and this PQ. Okay. What we will do? Construction. We'll only join AC and PQ. Construction. Join AC and PQ. Now let's see if this is the common base. AQ is the common base. Then this is one triangle. ACQ is one triangle and APQ is one triangle. Okay. So triangle ACQ and triangle APQ are having common base. AQ. Common base is AQ, and between the same parallels. And what are the parallels? AQ and CP. It is given. Same parallels AQ and CP. Therefore, area triangle ACQ is equal to area triangle APQ. Okay, from the theorem. So area triangle ACQ equal to area triangle APQ. ACQ and APQ. Now you see what is common here. This is the common part. So when we subtract this common part, triangle ABQ. Okay. Now this is, let us suppose this is 1. Now subtracting, we can subtract the equal part. Now subtracting area ABQ in equation 1. Okay, both sides we will subtract. That means what? Area ACQ minus area ABQ. Alright, that is equal to area APQ minus area ABQ. We can write it. This implies ACQ minus ABQ equal to this one, ACB. Area ACB is equal to, and this minus this equal to this one, area PBQ equal to area PBQ. Now this is important. These two are having equal area. These two are equal. ACB and PBQ are equal. Now when you look, this is a parallelogram. ABCD is a parallelogram and this is a diagonal AC. That means this area is equal to this area. Both are congruent. The diagonal bisects, divides the parallelogram into congruent triangles. That means this area is equal to this area and this area is equal to this area. Also this is equal to this. That means what? That means this parallelogram and this parallelogram will have equal areas. Let's write it. Now in parallelogram ABCD, area ACB is equal to area ACD. Why? Because diagonal of a parallelogram divides it into two congruent triangles. Divides it into two congruent triangles, and that is why the areas will be equal. Same is here. This PBQ equal to PQR. Area PBQ is equal to area PQR. Now also ACQ equal to APQ. ACB equal to PBQ. ACB is equal to PBQ. Now this equal to this also and this equal to this also. So area ABCD equal to area PBQR. Therefore, from 1, 2 and 3, from 2 and 3, therefore from 2 and 3, area ABCD is equal to area, which one? PBQR. PBQR. We can write this, proved. From 2 and 3, ACB, PBQ, PQR. Okay, ACB, sorry, this one is 3 and this one is 4. So from 2, 3 and 4, like this we can write. From 2, 3 and 4 we can say that this area ABCD is equal to area PBQR. Okay, so I hope everything is clear. Now let's move on. Now let's solve this third question. The question is, in the given figure ABC and ABD, are two triangles on the same base AB. Okay, if line segment CD is bisected by AB at O, okay, then we have to show that area ABC is equal to area ABD. Okay, so let's solve this one. And for this we will have to draw a construction. So the construction is because directly we have no clue, we cannot do anything. We need to draw two perpendiculars like this, perpendiculars. Let us know this is C, M and D, N. Okay, draw perpendiculars CM and DN on AB. Okay, now what we will do, we will prove these two triangles CMO and DNO congruent. So in triangles CMO and DNO, what we have? OC equal to OD. OC is equal to OD, it is given. All right, this angle is equal to this angle, vertical opposite angle. So COM, angle COM is equal to angle DON. These are the vertically opposite angles. And the third one is this 90 degree. This is also equal. Angle CMO equal to angle DNO, 90 degree. Therefore by AAS we can write angle side rule. Therefore by AAS rule we can say triangle CMO is congruent to triangle DNO. Okay, and by CPCT, corresponding parts of congruent triangles, CPCT, we can say that CM is equal to DN. Now area of this triangle ABC, area ABC is equal to what? Half of base into height. Base is what? AB, and height is what? CM. Similarly, area ABD is equal to what? Half of base into height. Base is the same, AB, and height is DN. Now you see CM equal to DN. That means what? These two values are equal. Therefore area ABC is equal to area ABD, because all the rest are same, only this was the different, and this is also equal, CM equal to DN. That is why these two triangles areas are equal. Okay, so only a few, just a small construction, and this problem is solved easily. Okay, so let's move on. So let's solve this fourth question. In a triangle ABC, E is the midpoint of median AD. This is the median AD and E is the midpoint of this median. So we have to prove that area BED is equal to 1 by 4 area ABC. Okay, let's see. Let's solve it. Solution. We will use one property, that median of a triangle divides it into two triangles of equal areas. Median of a triangle divides it into two triangles of equal areas. We have read this one and we are going to use this property. Median of a triangle divides it into two triangles of equal areas. First of all, let's apply it here in triangle ABC. AD is the median, so triangle ABD and ACD will have equal areas. So triangle ABD is equal to area triangle ABD is equal to ACD. All right. Now if you see, this E is also the midpoint of this side AD, and when this vertex B joins with E, that means this BE is the median of this triangle ABD. So we can write now BE is the median of this triangle ABD. This is the triangle ABD, this is the side, and B, this is midpoint, so B is the median. Therefore we can write that area ABE equal to area BDE. Area ABE is equal to area BDE. Let us suppose this is second. Similarly, this vertex is joining here C, that means what? In triangle ACD, this is the median. Also, CE is the median of triangle ACD, That means what? This triangle and this triangle will have equal areas. Triangle ACE, area ACE is equal to area CDE. Let us suppose this is third. Now area ABC equal to what? Area ABC equal to ABD plus ACD. Area ABC is equal to what? Is equal to area ABD plus ACD. Also ABD and ACD are equal. Okay, and ABD is also divided into two equal triangles. That means what? That means these four triangles are having equal areas. Okay, that means these four triangles are having equal areas. Therefore, and let us suppose this is 4. Therefore, from 1, 2, 3 and 4. Therefore, from 1, 2, 3 and 4, we can say that area, this BED or whatever, all are equal, BED, CED or whatever, but it is, we have to prove BED. Area BED is equal to 1 by 4 area ABC. We can write it directly because all the areas are equal. Alright, so basically we are using this property. If you don't remember this property, then this problem will be hard to solve. So we have to remember everything. Median of a triangle divides it into two triangles of equal areas. Alright, let's move on. Now let's do this last question, fifth one. In the given figure, area DRC is equal to area DPC, okay, and BDP equal to ARC. Where is BDP? BDP is equal to ARC, okay. We have to show that these two quadrilaterals ABCD and DCPR are trapeziums, okay. So let's solve it. Let's see the solution. So basically we have to prove that this ABCD and DCPR are trapeziums. That means what? That means we have to show that this AB is parallel to DC and this DC is parallel to RP. If we show only this, that would be sufficient to say that this is a trapezium and this is also a trapezium, okay, because this is the property of trapezium. Alright, so first of all, area DRC, we have been given area DRC is equal to area DPC, DRC and DPC, okay. And second one is, let's write it, area BDP is equal to area ARC. Alright. So from the first one, area DRC is equal to DPC, okay. DRC and DPC. Second one is area BDP and ARC. So from this one, second one, we are using this one, and we subtract from this triangle BDP, we subtract this DPC. So BDP minus DPC, let us see what happens. BDP minus DCP. Area BDP minus area DPC is equal to what? BDP minus DCP is equal to this one, BDC, area BDC. Okay. Similarly, from this ARC, we will subtract what? We will subtract this DRC. Okay. Area ARC minus area DPC, that is equal to what? That is equal to area ADC. This is 1, this is 2, and from this area BDP we subtracted this one, area DPC, and from this area ARC we subtracted this one. Alright, we can do it, both are equal. So we get area BDC equal to area ADC. Basically we got this one, area BDC is equal to area ADC. BDC equal to ADC. That means what? That means this and this are parallel, because this is the common base and these two triangles are having equal areas. That means from the converse of that theorem we can say that AB is parallel to CD. From the converse of the theorem, which theorem? That triangles having same base, and between the same parallels are equal in areas. So from the converse of this theorem we can say that AB is parallel to C and D. That means ABCD is a trapezium. Okay, it is proved. So basically we are using both of these equations, and we subtract the equal parts. From Euclid's axiom we can do it. We can subtract equal parts, and then we get this one, area BDC and ADC both are equal. And similarly you can do this one also, DCPR. Similarly you can do, you can try it by yourself. You have to only subtract two areas. All right, you can do it, it's an easy thing. So let's close this one, let's conclude this. Okay, so friends, you saw that we have solved some 5 questions based on the theorems and based on the studies which we have made on this chapter. So like the median of a triangle divides it into two triangles of equal areas, and of course the parallelograms on the same base and between the same parallels are equal in areas. The triangle on the same base and parallelogram on the same base between the same parallels is half of the area of a parallelogram. So based on these theorems we solved some 5 questions, and the questions were very good. So I hope you liked the video. Let's conclude this chapter here, and from the next video we will move on to chapter number 10. Okay, circles. So thank you for joining me.